In this video, I am going to show you on how to solve a exact differential equation. So we have here a first example, 3x squared plus y squared dx plus 2xy dy is equals to 0. So we have here and this will be our two function. This will be our function m and our function n. So the next thing, the first thing you have to do is test the exactness of both functions. So in testing the exactness, we'll simply get the partial derivative of m in terms of y. So the partial derivative of m in terms of y will be 2y, and the partial derivative of n in terms of x. So the derivative of 2xy is 2y. Next, therefore, this is a exact differential equation. So let's proceed. Let's integrate our function m with sin x dx is equals to our function m, which is 3x squared plus y squared dx, and add on a generic function in terms of y. So integrate both. We have our psi is equals to the integral of 3x squared dx is 3x cubed over 3 plus the integral of y squared dx is x y squared plus our generic function in terms of y. So we can cancel this out, so the remaining values in our side is x cubed plus xy squared plus g of y. So next is we will get the partial derivative of our psi in terms of y. So the partial derivative of psi is, in terms of y, is 2y plus g prime of y. And then we will equate this into the value of our n in our n function. So our n is 2xy, therefore this will be 2xy, 2xy, and cancel out. We have x of y is equals to 0, and then to get the value of g of y, we will integrate this. So our g of y is equals to c, and substitute our value of g of y is c. So our final answer will be x cubed plus x y squared is equals to c. So this will be our final answer. Our next example for exact differential equation is 1 plus cosine x dx minus dy is equals to 0. So again, we will first test the exactness. This will be our m, and this will be our n. So in testing the exactness, we will get the partial derivative of m in terms of y. So since it has no variable of y in our function m, so the partial derivative of m in terms of y is equals to 0, and our partial derivative of n in terms of n is also equals to 0. So therefore, since both m and n has an equal partial derivative, so it is an exact differential equation. Next is we will integrate our function of m. Psi x dx is equals to our m 1 plus cosine x dx, and add on a generic function in terms of y. So integrate our psi is the integral of 1 dx is x plus the integral of cosine x dx is positive sine x, and plus our generic function. Next is, since we have our value of y, next is we will get the partial derivative, our partial derivative of psi in terms of y. So again, since our psi has no y variable, so its derivative is 0. So we only have g prime of y left, and equate this into our n, which is our n is negative dy, so we have negative 1. So our g prime of y is equals to negative 1, and then to get the value of g of y, we will integrate this both. So our g of y is equals to negative y plus c, and substitute the value of y into our general equation, which is x plus sine x minus y is equals to c. So this is our final answer.